Hello children. Yeah, in today's class we'll be discussing about a very interesting and a very vast topic, but as per you understand I will make it simpler, and the topic is gravitational waves. Gravitational waves. Now as you see waves in water, now suppose when the water is left undisturbed, when the water is not disturbed at all, you see calmness, whereas as soon as you put a stone into that, you see the ripples formed. Same way ripples are formed in the space. So interesting, right? Same way the ripples are formed in the space when massive objects in the space move. Like it can be a star, it can be any other massive objects. When they move in the space, when they start rotating, they give out gravitational waves. Means when such massive objects, when astronomical objects in the space, when they move, they create some sort of distortion. They create some sort of imbalance in the space. And these distortion or these disturbance which is created in the space are called as gravitational waves. Now this gravitational waves was first given by again Albert Einstein, not Newton. Albert Einstein in his theory of relativity, which was published in the year 1915. He, in that theory of relativity equation, he had suggested about gravitational waves. So in the equations which he gave, he also mentioned about gravitational waves. So we got gravitational waves in the year 1960 from Einstein, from Sir Albert Einstein. He was the first person who predicted about gravitational waves. Einstein predicted it in the year 1916, but in the year 2017, gravitational waves were first detected on the earth through certain instruments which were again created by humans, and three physicists had made this instrument called as LIGO. Okay, LIGO. Though not only three physicists, these three physicists got their Nobel Prize for invention of this instrument. There were many we have already studied about electromagnetic waves like gamma rays, X-rays, okay, ultraviolet rays. These all are the electromagnetic waves that we have studied about in our lower class. Now gravitational waves are different waves. These waves are created by the astronomical objects in the space. They are created by astronomical objects in the space, and it was detected by the instrument called as LIGO. Now LIGO is nothing but Laser Interferometric Gravitational Wave Observatory. Now to detect the gravitational wave, we humans constructed an instrument on the earth, and through that we came to know that the prediction which was done by Einstein in the year 1916 was proved to be correct almost 100 years later in the year 2017, so in the month of September 15, I think so. So on that day, this LIGO, they detected the gravitational waves. Now LIGO is a big instrument. It consists of two tubes which are of equal length. Okay, whenever gravitational waves is detected on the earth, as it travels, as it touches the earth, it is first detected by the sensitive cells present in this LIGO. Now whenever there is gravitational waves, it is observed that these two tubes which are of equal length shrinks to a certain amount. Now through a naked eye we can't make out. It is very less amount. To a very less amount, the tube shrinks. And this shrink is because of the gravitational waves which has travelled from the space to the earth. Now the energy which is released by the gravitational waves are massive energy which can destroy the whole planet. But luckily, when the gravitational wave reaches the earth, the intensity becomes very less. So we are safe. Now, how did Einstein describe the gravitational waves produced in the space? He said that the space is made up of a fabric, like a sheet of elastic material, completely elastic material. It can shrink, it can extend. Okay, we have the space. Okay, it's a big sheet of fabric, and then we have lot of astronomical bodies in the space. Some are heavy, some are lighter. If you have an astronomical object in the space, now this fabric will get distorted. There will be little bit shrink. It will shrink. Whereas if you have a heavier body into the space, we have a heavier mass object, then the shrink will be more. Okay, here the shrink is less, whereas here the shrink is more. Now when there is a disturbance, shrink means it gets, as you have ripples in water, same way there is ripples in the space. Okay, the uniformity will get disturbed. So this condition leads to formation of gravitational waves. This condition leads to formation of gravitational waves. Now, the intensity of gravitational waves become massive, enormous when any two astronomical objects collide with each other. Like first it was observed when two black holes collided with each other. Okay, so when these two astronomical bodies, when they collide with each other, the source of energy produced is so enormous that it can burn off the whole earth. But as the waves reaches the earth, because of the distance, so many light kilometers of distance, no? So because of the light years traveled, because of the massive distance between the earth and the space or the universe, we on the earth, we are not at all bothered. We don't even feel the gravitational waves. Only thing is that it is detected by the instrument called as LIGO. Now what is the use of these gravitational waves? With the help of gravitational waves, we can study more about the bodies which are present in the space. We can get till now we know about planets, we know about stars, we know about asteroids, but there are many massive objects in the space which we have not talked much about. So it's a big mystery like thing. So with the help of gravitational waves, more mystery will be revealed. We can study space into a higher extent with the help of gravitational waves. Having done that, let us now take our topic ahead with the next topic called as free fall. Free fall. Very easy to understand. Free fall is very easy to understand. Suppose you drop it. If I drop any object, now here we know that here atmosphere is present. So if I drop any object, let me drop a paper, okay, or a heavy object. Before the paper reach, what will reach first? Obviously the heavier object, like a stone and a feather, famous example. Okay, a stone and feather, if I drop it here through your 10th floor or 15th floor or 3rd floor, if you drop a feather or a stone, we all know that first what will reach? A stone will reach, because a feather will be acted upon by two extra forces. It will be acted upon by gravitational force. Also, it will be acted upon by the buoyant force present in the air. The air will exert an upward force onto the feather, and because of that the feather will go here and there, and then finally it will reach the floor. Whereas onto the stone, the buoyant force and the frictional force will be exerted, but that force will be lesser because the mass of the stone is more. So heavier objects will experience less buoyant force and frictional force, whereas lighter object will experience more buoyant force and frictional force. Because of these two extra forces, feather will reach onto the floor a bit late, whereas heavy objects will reach the floor faster. Now suppose there is no atmosphere, means we are talking about only vacuum. When there is no atmosphere, no air around, only vacuum is present. At that time, if I drop a feather and a stone, both will reach at the same time. Okay, why? At that time, they are only experiencing free fall. So what is a free fall? If an object is acted upon just by the gravitational force of the earth, that kind of motion is called as a free fall. When an object is acted upon by gravitational force alone, when an object is acted upon by gravitational force alone, it is called as free fall. So is free fall possible in this room or where you are sitting? Is free fall possible? No. Free fall is possible only in vacuum. Free fall is possible only in vacuum. And see, the spelling of vacuum is like this. Many of you might be thinking of putting VACC. No, VACWM. Okay, what is free fall? When an object is acted upon by gravitational force alone, only gravitational force is acting on the object, that time we say that the object is undergoing free fall. Understood? So, when you have vacuum, when you have only vacuum in the room, that time any object you drop, both the object will reach at the same time. Mass is not a factor there. But when you are dropping it in the atmosphere where there is air present, because of the frictional force exerted by the air and the buoyant force, two forces which are buoyant force, which is the upward force, and the frictional force, plus the main force, that is gravitational force. Okay? So because of the gravitational force, all the object falls down. When you have vacuum, these two forces will be absent. So at that time, the only force acting on the body will be gravitational force. Such type of fall is called as free fall. How will you consider the equations of motion in a free fall? Equations of motion, you remember the equations of motion which we had done in our 9th standard. Okay, when an object is under free fall, we consider the, suppose any object which is undergoing free fall. Suppose this is the chalk. If I leave it, initially, what is the initial velocity? It is under rest. So initial velocity will be, under rest means initial velocity will be 0. So for free fall, initial velocity is always 0 meter per second. That you have to register. While solving numericals, I'll ask you. When you are talking about free fall, the initial velocity is always 0. As soon as I drop it, what will happen? The velocity increases, and finally when it reaches the floor, again the velocity becomes 0. Understood? Now we will write down how the equations of motions can be written when the object is undergoing free fall. Okay, let's start. So first I want you to write down the definition of free fall. Write down. When an object moves under the influence of, right, I want you to write and by heart it now itself. When an object moves under the influence of gravitational force alone, when an object moves under the influence of gravitational force alone, then this is called as free fall. Then it is called as free fall. When an object moves under the influence of gravitational force alone, then it is called as free fall. Repeat with me. Yes? Okay, said? Okay, fine. Now, let us derive the equations for free fall. We all know what all are the equation? V is equal to U plus AT. First equation of motion, not law of motion. Equation of motion. We said for free fall, U is always 0. So, put 0 here. So, therefore, V is equal to 0 plus, when an object moves under the influence of gravitational force alone. What is that gravitational force? If it is only gravitational force, should we write A? It is G, force of acceleration due to gravity. So A becomes G because it is because of gravity. So V is equal to, in place of U0 plus GT. So therefore, V is equal to GT. So this is the equation when you have free fall. V is equal to GT. Now second equation. S is equal to UT plus half AT square. This is the equation for any object. But if the object is undergoing free fall, we know U is equal to 0. So your equation will be S is equal to UT. 0 into T will be 0. Half under the influence of gravity, so A will become G t square. So therefore S is equal to half gt square. This will be the second equation for free fall. Now the third equation. What is the third equation? V square is equal to u square plus 2as. So therefore V square is equal to u is 0 plus 2gs. So therefore V square is equal to 2gs is the equation for free fall. So first, second and third equation will get this form when the object is undergoing free fall. Okay, now motion of satellite. It is, you should know that in the space there is no atmosphere. So there is no atmosphere, so the movement of satellites is only because of the gravitational force of the earth. Okay, so then that is also example of free fall. Okay, in the numericals we will be using all these formulas. Okay, now last thing, when I throw an object, okay, when I throw an object in vertically upward direction, okay, when I throw an object vertically upwards, that time I am doing the work against the gravity. Gravity's direction is vertically downward direction. When I throw an object in vertically upward direction, that time you will write down the acceleration to be minus g. Okay, whenever the object is thrown in vertically upward direction, you will write the acceleration to be negative or minus g. For object which is falling in the downward direction, it is acted upon by the gravitational force. So that time it will be g, whereas when the object is thrown vertically upwards, you are doing work against the gravity, you will write that time g as minus g. Okay. So in today's class, we discussed about a very interesting topic, gravitational waves. Okay. The instrument which detects these gravitational waves, LIGO, and then we discussed about free fall. Okay, I want you to by heart the definition of free fall and the full form of LIGO. Okay, thank you.